Okay, so starting from today, we are going to deep dive into the Oracle database server architecture. Okay, and this will be the first session on the architecture of this whole concept of Oracle database. Okay, so let me share my screen. Is it visible now? Can
Yes,
anyone
bro.
confirm? Yeah, okay, fine.
Yes, visual.
Okay, fine. Yeah. Okay. So basically, we are going when we say that we are going to look into the Oracle database server architecture. If we have to talk about the term architecture in layman's term, basically what it means is you are going to put all the components of whatever things architecture we are going to discuss. Okay, if we take an example of house architecture, okay, and if you're going to build a house, you hire a professional architect and you sit with the architect and then you decide on all the things that you have in your mind. Okay, so you let the architect know about the say the design that you have in mind, like how many bedrooms you want in the database, sorry, in the house, then how many garages do you need. Okay, then what would be the placement of wardrobes in each of those bedrooms. Okay, uh, which specific area will be reserved for the kitchen. Now within the kitchen you are going to reserve a specific area for say the fridge. Okay, then there has to be a dedicated area say for the washing machine. Okay, and all the concealed piping, all those things will be planned accordingly, because you can't place the washing machine at any random place in the house, right? There has to be a dedicated place for that. Okay, so you put all those things on a paper. Okay, and that you call it as an architecture of the house. Okay, that is in layman's term. So when we put the same example in terms of Oracle database, okay, so it brings us to something called as the memory component and the physical component. Okay, so broadly, your Oracle database server architecture is divided into two parts. There will be a memory component and there will be a physical component. Okay, the memory component, we call it as the instance. Okay, and why do we call it as the memory component? Because this instance that you see it over here in this diagram, this instance will be loaded in the, or it will be present in the memory of the server. Okay, so that's why it is called as the memory component of the Oracle database server. Okay, the next component of the architecture is the actual database itself. Okay, and why is it called as the physical component? Because it will be occupying some or the other storage space at some space at storage level. Okay, you'll be able to see those files. Okay, so anything that is present on your hard drive or on the storage, we call them as physical component. Okay, so that's why we say that Oracle database server architecture, it consists of two components. First one is the instance, which is present inside the memory, that is inside the RAM of the server, and the physical component which will be present on the storage. Okay, clear with that? Very simple thing: memory
Yes,
component,
yes, clear,
physical
clear. Yeah.
component. Yeah. Okay, So when we say that this instance, which is the memory component present inside the RAM of the server, it automatically means that if something goes wrong with the server, okay, or if for some XYZ reasons your server crashes, that means the instance which is present or which was present in that RAM on the server, it will get wiped out, correct? Is
Yes,
that
yes.
right? Yeah. So understand this, that the instance which is present inside the RAM, if something goes wrong with the server, the instance will get wiped out. Okay. And you as a DBA, you will need to restart that instance. Restart the instance, when we say restart the instance means the instance has to be loaded into the memory again. Okay. Okay. So now let's check into this next diagram. Okay. So this diagram basically it is showing a couple of more components of the architecture. Okay. So what happens in case of Oracle database server is, if this is your database, okay, it is occupying some storage space. Okay, all your data will be present, of course, inside this database. Okay, but to be able to access that data which is present inside your database, you will have to, or the applications has to actually connect to the instance. Okay, so in case of Oracle, if an application or if a set of applications wants to connect to the database, they want to access the data that is present inside this database, they have to basically connect to the instance first. Okay, so the users or the applications, they always connect to the instance first, and through the instance they will be able to access whatever data that they want to consume. Okay, now in this diagram, you see that we are showing the instance as a door. Okay, why specifically it is being shown as the door? Because we also say that the instance, which is the memory component of the architecture, it can be called as a door to the database. Okay, so like I said in the previous slide, that this instance, if it is present in the RAM, okay, and if this instance is not loaded inside the RAM, okay, the applications won't be able to connect to the database. Okay, so in case of Oracle, what happens is the applications has to connect to the instance. Okay, and through the instance they will be able to establish a connection to the database. Now here, if you see, I have represented only one database, but there are two instances. Okay, why is it so? Because at any given point in time, a database can have multiple instances running on different servers. Okay. And why is that required? Let's say that uh, you have got this database and there is only one instance present for that database. For some XYZ reasons, if the server becomes unreachable, okay, if the server becomes unreachable, in that case, your database will be, the users or the applications will not be able to connect to the database, right? Are we clear with that?
Yes, bro.
Anyone else apart from Deepak? Azaz,
Yes,
Mahesh, Abhishek?
yes, clear, clear.
Yes, yeah.
Yeah. So because, so if you are having only one instance for the database running on that specific server, and that server itself becomes unreachable or it has crashed, it is not accessible to the application, the users will not be able to connect to the database. That's why Oracle has given you the possibility to have multiple instances for a database, so that if one of the instance is unavailable for any XYZ reasons, the applications or the users can still connect to the database through the other instance. You getting it? So a database can have multiple instances. Okay, it is one of the features of ensuring high availability within the database. You are ensuring that your database is highly available. Okay, now let's just take an example of the IRCTC database. Okay, now in that case, if they are having only one instance of the database, and you know how busy the IRCTC website is, right? For some, because of for because of some XYZ reasons, if that sole instance, if the only instance becomes unavailable, that means none of the users across India or across the world, they will be able to connect to the IRCTC database. That's why they have to ensure that they have configured multiple instances for their database. And that's how all the production databases run in the industry. None of the production databases will be running on a single instance configuration. Your development or your test environments, they will definitely be having only one instance for each database. Okay, but for the production environments, you won't find companies who are having only one instance. Okay.
Yes, and the same data will be replicated in the both the instance, not those
Yeah,
instance as we have.
exactly. They will be, it's not for data replication. Okay. Instance
Okay,
is not for data replication. It is only giving you access to the database. Okay, your data is not getting replicated across these two things, these two instances. Data replication is altogether
okay,
a different concept. Instances are not used for data replication.
okay. I get your point.
Okay. Anyone else, if you have any doubts regarding this as of now? Azaz,
No, bro.
Mahesh.
Yeah.
Okay, fine. So let's look at the actual components of the Oracle database server in much more detailed manner. Okay. So when we look at this diagram, you get to see a lot of components over here. Okay. And we will start with this specific icon, which is for the user process. So what exactly is a user process? Okay. Say that you want to you want to connect to the IRCTC website. So as soon as you open the IRCTC website, as soon as you start that application, say if it is having an mobile app, so as soon as you start that or you open that app without logging into the database, okay, I'm saying that you have just opened their website, you have not put in your user ID or password. Okay, so as soon as you have opened that website or application, something called as a user process gets created on your system. Okay, so on the user's end, something called as a user process gets created. So we can say that user process is a user side process. Okay, now why exactly is this user process required? Okay, we'll see that as well. Now, because you want to connect to the database of IRCTC, you have started that application of IRCTC or say the website, okay, and then you will be putting in your credentials, okay, whatever username and password that you have, right? Everyone must have a user ID and password, okay? So the user puts in his credentials. Next is that credentials needs to be verified. Okay, it can't be that any user, I mean anyone comes in and without registering, without having a valid login credentials, they will be able to connect to the database. Okay, so the user has to be authenticated, right? So as soon as the user provides the user ID and password, there is something called as a listener process. Okay, that you see here in this diagram. Okay, this listener process, it is running on the server side. It is a server side process. Okay, so the job of this listener is to fetch the user credentials and get it verified. Okay, get that validated with the database, right? All the users who wants to connect to the database, they have to be verified. They have to be, their credentials has to be validated. So that is the job of this listener process. The listener process, it will be running on the database server. Okay, now it might happen that the password which the user has provided, it is correct or it may be wrong. There are two scenarios, right? Either it will be correct or it will be wrong. So let's assume the first scenario, that the credentials are correct, the password is correct. In that case, what this listener process will do, it will create something called as a dedicated server process for that user. Okay, so what we are saying is, if the user gets authenticated successfully, okay, something called as a server process gets created on the server. Okay, and it's a dedicated server process. Okay, so if the credentials have been validated successfully, okay, in terms of Oracle, we call it as a session has been established. Okay, so when exactly a session gets established? When the user's credentials are verified successfully. At that time, we say that a session has been established. Now, let's consider the other scenario, that the credentials are not correct. Okay, in that case, the listener process will, in that case, the user session will not be established. Okay, and the server process will not be created for that user. Okay, so I mean, take it as a question that if the user's session, or if the user has not provided correct or valid credentials, in that case, will the server process be created for that user?
No,
Anyone?
no,
No,
Others, Mahesh or Azaz?
no, it's not created.
Exactly, yes. So the server process gets created only if the user has provided the correct credentials, okay, and a session then gets established. Clear with that? So for every user process, there will be a dedicated server process. So if at any given point in time, there are 500 users or thousands of users connected to your database, that means that many number of user processes are running on their end, on the user end, and on the server end, you will see their dedicated server processes. Okay. And again, discussing about this listener process. This listener process, its job primarily is to accept the connection request, right? That's what we said, that it will accept, it will validate the user credentials. Okay, so its job is to accept the connection requests that are coming for the database. Now, it may happen that on the server, now all of you are SQL DBA in this batch, so you know that on a server, it's not that there will be only one database that runs on a server. There will be multiple databases that runs on a server, right? So similarly, in case of Oracle as well, there will be multiple databases running on a single server. Okay, there may be multiple databases running on a single server. In that case, what you might see is a single listener process is accepting the connection request for all those databases. It is possible that a listener process is accepting the connection request for multiple databases running on the single server. Okay, or it might also happen that there will be one dedicated listener process for each of those databases running on that server. Getting it? Clear with that? A single listener process can also accept the connection request for multiple databases running on the server, or at the same time you might see configurations that there are I mean for every database there is a dedicated listener process. Clear with that, everyone?
Yes.
Yes, bro.
Yes.
Yeah. Now, for the user to be able to connect to the database, we said that the user starts an application or a mobile or app or whatever interface that he uses to connect to the database. Okay. So the connection request gets accepted by the listener. That is also fine. Okay. But then the user also has to know the details of this listener, where exactly this listener is running, where exactly the database server is. The database server is as in the IP address of that specific database, in terms of, if we talk about in terms of websites. Okay. Or the say the domain wherein that database is present, the host name of the database server, all those things the user has to be aware. Now, do you think that it is possible for the user to remember all this information? The IP address of the server, the name of the listener, the port on which this listener runs. The users, they won't be able to remember all these information. The max that they will remember is their own credentials. They forget that as well many a times, right? So the users can't remember all these information every time. Okay, so that's why what Oracle has done is Oracle provides us something called as net configuration files. Okay, what are those net configuration files? Those net configuration files will be present on the user end. Okay, or it will be present on the application servers. Okay, and those net configuration files will be having the details of this listener, the details of this listener as in what is the name of the listener, on which port it is running. Okay, on which server this listener is running. Okay, whether type of protocol it is accepting the connection on. Okay, so all those information regarding the listener and the database server will be present inside the net configuration files, which will be running on the app, or which will be present on the application servers. You're getting it?
Yes.
Any doubts regarding this listener process, or these three things: user process, listener, and the server process, and other details that we discussed about listener?
No, as of now.
Okay, fine. If you have any doubts, stop me then and there, and then we will clarify, we'll discuss on that, and then we'll move ahead. So let's talk about a scenario wherein the listener has authenticated the user successfully, and now we are saying that a dedicated server process has been created for that user. Okay. Now what happens? What is the job of this server process? Okay. So the job of this server process is to execute each and every request that the user submits. Okay, so if the user fires a simple query like they select name comma employee ID from employees, okay, it's a very simple select statement, right? So in that case, the query execution, okay, to execute that query on the user's behalf, that is the job of this server process. Okay, the actual query execution for the user will be done by the server process. Okay. Start it in presentation mode again. Yeah. So what also happens is, when this server process gets created, something called as a PGA, okay, which is also called as a program global area, it gets established, or it gets created inside the server memory. Okay, so as soon as a server process has been created for this user, something called as a PGA gets created inside the server memory. Now, this part that you see in this diagram, I have labeled it as the instance. Okay. So this instance is where exactly is it present? It is present inside the Azaz. Can you answer that?
Memory.
Where Azaz?
Yes, yes, bro. Tell me.
Where is this instance present? Where it runs?
It's present in the memory.
Yeah, exactly. So it is present inside the memory of the server.
Hmm.
So what I said was, as soon as the server process has been created, a dedicated PGA, which is also called as the program global area, gets allocated for that specific user. Now, if you say in this diagram, there is another PGA, okay, and all the components inside that PGA are exactly similar. It means that whatever is the number of users connected to the database instance, all of them, they will be having their own dedicated PGA. So for every server process, there will be a dedicated PGA present inside the instance. Clear with that? There is a common misconception amongst many beginning DBAs that there is, for all the users who are connected to the database, there will be a common PGA. It's not like that. PGA is a private area. It is also called as a private area. That means whatever information that will be present inside the PGA, okay, say inside this PGA, and if this PGA has been allocated for this specific user, only this user will have access to the information that is present inside this PGA. Okay, this user cannot access this specific PGA because this PGA is created for some other user, and that's why we say that PGA is a private area. Okay, it is not a shared area. Understand that very clearly.
Yes. So once the user session is closed, so this PGA will get closed also.
Yeah, exactly. Yes.
Okay.
Yes. The memory that has been allocated to the PGA, it will need to be cleared. Okay. So when exactly the user session or user process will get closed? If the user does an exit by himself, or for some XYZ reasons, his session is it gets deactivated or timed out. Okay, so at that time the user session will get cancelled, or it will, and at the same time the PGA needs to be deallocated as well, right? Otherwise it will keep on accumulating unnecessarily. All this memory area will get wasted, right?
Yes.
Okay,
Fine. Fine.
so coming to the PGA now. Now, why exactly is the requirement of this PGA? What function does it serve? Okay, so the PGA basically, for that we have to look at the internal components that is present inside the PGA. Okay, so there is something called as a runtime area, then persistent area, which are actually part of the private SQL area. Now, what are those? Okay, for the understanding that, we'll just take an example. Okay, let's say that we have got a couple of users. Okay, this is the first user, and the user, he we are assuming that they are already connected to the database. Connection session has been established. Okay, so when this user fires a query, say this select name comma manager from employees where location equals to Mumbai. So what he wants to fetch from the database is names and the corresponding manager name for all the employees who are present in Mumbai location. Similarly, this user, he wants to see the details of all the employees who are present at the Hyderabad location. Okay, so because their session has been established, we say that they will have a dedicated PGA. Both of them will have a dedicated PGA. Okay, so what information will be present inside the runtime area? Let's say that if this query is going to return say 10,000 rows. Okay, if this query is going to return 10,000 rows and this query is going to return say 20,000 rows. Okay, so when that query is executing, when it is in the result set are being returned to the user, at that time somewhere this information needs to be stored that out of these 10,000 how many rows has already been returned to the user. Okay, for this query, when those 20,000 rows are in transit, when those are being returned to the user, so at any given point in time, how many of those rows has already been returned to the user? Okay, that information gets stored in the runtime area. Are we clear with that,
Yes. So incomplete information, those which are already fetched, will
everyone?
be in the runtime
The
runtime
query's
area.
execution state information is getting stored inside the runtime area. Abhishek,
Yes, yes, yes.
others.
So before the execution is completed, it will store information till the before the execution is completed, right?
Yeah, so till what point you guys heard me?
Runtime area. So my one doubt was there. So before, see, we are at the 99.9% of the, we run one query and which is completed till 99.9%. So till 99.9% it will be in the runtime area. So once it is 100%, it will move from the
Yeah,
runtime area,
Dhruv,
No,
can't
right?
hear your
no, no.
voice.
Still you can't hear me?
Yes, you are audible. Am I audible?
Hello?
Yeah, I can hear you guys, and I suppose you people are also able to hear me, but someone
Hello.
in between that is not able to hear me.
Hello. Yes, you are audible. Am I audible?
Okay, so I am audible, right?
Yes, yes. You
Yeah,
are
yeah,
audible.
we are audible.
Deepak, can you confirm if I am audible or not?
Yes, you are audible, Dhruv.
Abhishek, can you confirm if I am audible? You just mentioned that I am audible. I can't hear you,
Hello.
Abhishek.
Hello. Am I audible? Hello.
Yeah, you are audible.
Okay, okay, okay. Fine.
Who's this? I think-
Abhishek.
Okay, okay, Abhishek.
Yeah, okay. So the next component that we see inside this private SQL area is something called as persistent area. Okay, and what information does it store? So we'll go back to our previous example again. Okay. Now, if you see these two users, they have fired pretty much similar query, only the location has changed, right? This user wanted to see the details of all the employees from Mumbai, and this user wanted to see the details of employees from Hyderabad. Okay. Now, instead of this, what these users could have done is they could have made use of something called as a bind variable. Okay. So what exactly is a bind variable? Basically, the application developers, they make use of the bind variables when they are writing the SQL queries inside their applications. Okay. So what they write inside the application is they will write this query, select name, comma, manager from employees where location equals to, and they will mention this keyword ampersand. Okay. What it does is at runtime, it will ask you to enter the location for which you want to see the details of the names and the managers. Okay. So consider a simple example. Let's say that you have got such n number of such users, hundreds of such users. Okay. So they will be accessing all this data through some application, right? Now the users, they will not be writing this query manually by themselves, right? They will be accessing all this data through the application, and application will have internally its own SQL statements written in it. Okay. So the application developers, they make use of these bind variables. Okay. So when this user wanted to see the details of employees from Mumbai location, at runtime, he only has to provide this location name. Okay. Mumbai. This user has to only give the location for which he wants to see the data. Then in this case, Hyderabad, the next it may be Bengaluru, next it may be Delhi or some other state, right? So whatever is the value of the bind variable that the user has provided at runtime, okay, that information is stored inside the persistent area. Did you guys understand this, or do I need to explain again?
Please once again explain the things
Yeah.
once again.
Yeah, sure, fine. So what happens is, in case of application, the way they get written is, they won't have queries like select name, comma, manager from employees where location equal to Mumbai, then another query wherein they will mention that select name, comma, manager from employees where location equals to Hyderabad. Okay. They will write a single query which will look something like this, which you see over here, the second example. Okay. Instead of the actual value in the query, they provide something called as a placeholder. Okay. This ampersand is called as a bind variable or a placeholder. Okay. The benefit of this is that instead of writing 20 or 30 queries for each of the locations at which the company has got their offices, they will have, the application developer will now write only one query. Okay. And he will specify a placeholder, so that if this user wants to see the data for Mumbai location, he will just provide the name as Mumbai over here. This user will have to only provide the name as Hyderabad over here. Some other user who wants to see the details of employees who are working at Delhi location, they will only specify Delhi at runtime over here. So it is enhancing reusability in the database. You getting it? Now is it clear?
Yes. Now clear. Yes.
Azaz, Mahesh. I am not sure. Are those guys still in present or they left? Okay, Azaz left. Okay, fine, no problem. Mahesh is there. Maniraj. Maniraj, you are getting all these concepts? You haven't spoken anything until now.
Yeah, Dhruva, a little bit busy and I'm listening all the things. I will go through once again.
Okay, fine. Carry on. No problem. Okay, fine. So, Abhishek and Deepak, you understand what information is stored inside the persistent area, okay? So, because this user only wanted to see the details of Hyderabad location, in the persistent area, what information will be present? It will be present Hyderabad for that specific query. For this user, he wanted to see the details of, say, Mumbai. So for that query, it will be stored as the persistent area will store the value as Mumbai. Clear with that? And why Oracle has provided that specific feature of placeholder or bind variable? To enhance reusability in the database. Okay. So these two components are present inside the private SQL area. The runtime area and persistent area, they are further present inside they are component of the private SQL area. Okay. Now, like I said previously, whatever information is present inside the PGA of this specific user, it will not be available to the user who is having a different PGA dedicated to his session. Clear with this much?
Yes, yeah, clear.
Yeah, fine. So the next component that we are going to see is something called as SQL Work Area. So what is an SQL Work Area? Again, going back to our examples. So now the same query, okay, the user wants to see the same data. It's just that now he wants all that information ordered in a specific manner. Right? In case of Windows files also, you do the sorting, right? You want the files to be ordered by name, or you want them to be grouped as per their file type. We do that kind of sorting, right? So if we go back over here, right? If I do sort by, right? I say type, correct? Or if I say sort by name. So we are asking Windows to do some kind of sorting. Similarly, if we look at this specific query, these two queries, the user wants the data to be ordered in specific manner. Okay. So that sorting of the data, where exactly that will happen. Okay. So that takes place inside the SQL work area. Okay. Clear with that? All the sorting or grouping, whatever the user wants to do, that bit will happen inside the SQL work area. Simple to understand? Abhishek and Deepak?
Yes, fine.
Yeah. The next component that we see is called as the session memory. So there is not much to be discussed about session memory. Just understand that it stores the normal logon information. Okay, what time the session was established, what is the current state, whether it state of the session, whether it is active, inactive. So all those session related information, logon related information will be present inside, or it will be stored inside the session memory. Okay, we as a DBA, we don't try to control anything about it. Okay. The next two components that we see inside the PGA is hash area and bitmap merge area. Okay. So these two memory components are also used for some or the other sorting operations. Okay. There is something called as a hash sorting that will happen in case of Oracle database. So if there are some queries which needs to do the hash sorting, okay, that in that scenario this hash area will come into picture. Okay. And similarly, this bitmap merge area also, it is going to be used for some kind of sorting purpose only. Okay. So these are the important components that we see inside the PGA. And
So
each of
what
sorry.
what would be the hash sorting?
So see, there will be SQL queries that the users are firing. Either they will be fired manually, or it will be coming from application. Okay.
Okay.
Now, if say there is some kind of operations which is doing hash merge join. Okay.
Okay.
In those scenarios, if some kind of hashing operation has to be done for the queries, in those scenarios, these hash area will come into picture. Okay, and similar thing applies to bitmap merge area also. Now, again, as a DBA, we don't try to control much about that unless and until there are some specific issues related to that. We normally don't get to see issues with that. But still, if at all you face issues, then only you try to go and check into the hash area or bitmap merge area. Otherwise, they are getting addressed by themselves. Okay. Now, what we as a DBA do with regards to the PGA is we allocate the PGA at the whole database instance level. Okay, we make use of a parameter which is called PGA aggregate target. Okay, and we specify a value to it, say for example 8 GB or 10 GB. That means we are allocating 10 GB of the memory. Okay, on the server we want to reserve 10 GB of memory for the PGAs. Now when I say 10 GB through the parameter PGA aggregate target, what you mean to say is whatever would be the number of PGAs getting allocated inside the instance, the sorry, the maximum amount of memory as a combined they can use is 10 GB. Okay, it's not that for every PGA you want to allocate 10 GB. Okay, the combined allocation will be 10 GB, and from that 10 GB, PGA will keep on getting allocated whenever a new session gets established. Clear with that, Abhishek, Deepak?
Yes, clear.
Yeah,
Okay.
Dhruv.
Fine. And furthermore, we like I said that we specify the sizing for PGA using that parameter. We don't try to control it further inside the PGA. Okay, we don't try to control anything inside, say, this runtime area, or we as a DBA, we need to allocate memory to runtime area or persistent area or SQL work area. It automatically gets allocated. Okay, we only size the PGA as a whole. All these things will be taken care of by Oracle itself automatically. Okay. Okay, fine. Next thing that we are going to see inside the memory or inside the instance is another very important component called SGA, which stands for Shared Global Area. So the primary difference between SGA and PGA is that PGA, it is a private area. Okay. SGA is a shared global area. That means whatever information that will be present inside the SGA, it will be available to use for all the users who are connecting to the database. Okay, that's why the name itself is SGA, which stands for Shared Global Area. Got the primary difference between SGA and PGA? Okay.
Can you please once again a difference between the PGA? I was
Yeah,
just
fine,
confused.
fine. See, so what we said about PGA was that it is a private area. Every session that gets established in the database, it will have its own dedicated PGA, right?
Yes, fine.
And the PGA information cannot be shared across the users. But when we talk about SGA, SGA is a shared global area. That means whatever information that is present inside this SGA, which you see over here, okay, it is available for use to all the users in the database. It's not like for every user or for every session, there will be a dedicated SGA that is getting created. There will be a common SGA for the entire database for all the users who wants to connect to the database. There will be a common SGA. Now it's clear, Abhishek?
Yes, fine. So so PGA will be for the for specific. It will be for the each session is process. We have different PGA, but SGA will be shared among all the DB components. Fine.
Exactly.
Yes.
For
Okay.
all the users, for all the sessions, there will be a common SGA.
Okay. Fine.
Okay. And this SGA and all the PGAs are present inside the instance, which is
Instance.
their memory component. Okay.
Yeah, fine.
Yeah. Now coming back to the SGA. Okay. So inside the SGA, the primary component that you see is the shared pool. Okay. Now look at the name itself. It is shared pool. So whatever information that you will see or whatever data that will be present inside the shared pool, it is available for use to all the users who are connecting to the database. Okay. Now coming inside shared pool, the first component that you see is the library cache. Okay. And then there are sub components inside the library cache. So what exactly is this library cache? What is the functionality of this library cache? Okay. So now again, let's go back to our previous example. Okay. So when this user fired this query, select name, comma, manager from employees where location equal to Mumbai. Okay. So if we go back to our query, the flow of our query execution, what will happen? What has already happened is a server process has been created for the user. For the user, a dedicated PGA has been allocated. Okay. And now the user has fired that specific query. So inside the library cache, what will happen is for this specific statement, okay, for this specific statement, something called as an SQL ID. Okay, what exactly is an SQL ID? See, the name itself, it is having ID. Okay, so each SQL statement in the database, it will have its own dedicated unique SQL ID that gets generated. Okay, so whenever the user fires a query in the database, whenever say this user has fired that query, whenever the user fires a query in the database, the SQL ID of that statement, okay, that will be stored inside the shared SQL area. Not only the SQL ID, the SQL text as well will get stored inside the shared SQL area. Okay, clear with this simple information that whatever queries are getting fired in the database, all those queries, their SQL text and their SQL ID will be present inside the shared SQL area. Clear with that, Abhishek?
Yes, fine.
Yeah.
Yeah,
Now,
fine.
now you need to understand why does Oracle need to store that SQL ID or SQL text inside this shared SQL area? What is the purpose of storing those SQL statements over here? Okay. So let's say that when the user has fired this specific query, okay, it might happen that after 20 minutes, the user fires this same query again. Okay. Then after another 20 or 30 minutes, he fires the same query again. If he keeps on firing the same query again and again. Okay. Now, when the query has been fired repeatedly, the user wants to see the same data, right? The user is trying to fetch the same data from the database. Now tell me, does it make sense that Oracle will keep on executing the same statement again and again repeatedly? Internally, does it make sense to do the same task again and again?
No.
No,
So it
it
will
doesn't
store
make
the SQL ID for the each queries.
exactly.
Okay.
So for enhancing reusability in the database, what Oracle does is when the query was fired, Oracle stored the SQL text and SQL ID in the shared SQL area. Okay. After that, now we'll move to the next step of the query
It's a kind of
execution.
buffer caching, no?
No, that is okay. You have moved to buffer cache. Who was this?
Okay. Mahesh. SQL buffer
Mahesh.
cache is
Mahesh will come to the buffer cache. Okay. We are at library cache only at this moment. Okay. So what happens is when the user has fired this query, I said that the SQL ID and the SQL text gets stored in the shared SQL area. Okay. Then to be able to return the result set to the user, okay, Oracle has to prepare something called as an execution plan. Okay. Oracle has to prepare something called as an execution plan. Now, what exactly is an execution plan? Okay. Now let's take a simple example that you have to travel from, say from Abhishek wants to travel from Noida to Hyderabad. Okay. Now there are a few possibilities. There might be direct trains available from Noida to Hyderabad. There might be direct flights available from Noida to Hyderabad. There might be flights which are running via Delhi and then to Hyderabad. So there are 2 or 3 possibilities, right? It might happen that one of the flight is traveling from Mumbai, I mean from Noida, he has to travel to Mumbai and then that flight goes to Hyderabad. Okay. So what exactly we are discussing is the various paths which we can take to reach the destination. Okay. If A is our source and say if C is our destination, we can directly move from A to C. Okay, that is one of the options. Okay, the other option could be that I come to this, then I go to this, and then I go to this, right? So in the end, we are reaching the same destination, right? But there are different paths available to reach that specific destination. So in terms of Oracle, we call it as the execution plan of a query. Okay. So whenever a user has fired a query, internally what Oracle has to do is Oracle has to find a way to fetch all those data from the database. That is, Oracle has to prepare the execution plan for fetching the data from the database. So what Oracle does, Oracle will prepare 3 or 4, or Oracle will find 3 or 4 execution plans to return those or to fetch those data from the database. So if this was the query that was fired by the user, Oracle will generate or find 3 or 4 execution plans, okay, to fetch all the data for returning from this query. But it is not going to use all of those. Okay, what it will do is it will choose the best execution plan out of those 3 or 4. Now, on what basis does it choose that best execution plan? Okay, so that is going to be based on 2 criteria. That is, the query should get executed in least amount of time and it should consume least amount of resources. Okay, so the execution plan which is going to consume least amount of resources on the server and which will get the data in least amount of time, that specific execution plan will be called as the best execution plan. You getting it? Like if at all there is a possibility to take a direct flight from Noida to Hyderabad, Abhishek will choose that specific path because it is going to take least amount of time, right? And in terms of money as well, if it is not going to take that much money, in that case, he will choose that specific option instead of spending too much time in the train or taking a via flight. Okay, he can go for the direct flight from Noida to Delhi. So what was the deciding factor over there? The timing. Okay, because in industry, the users want to get their data as soon as possible, right? They don't want to wait for the result set to be returned to them. Getting it?
Yes,
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 bro.
yes, yes.
Yeah. So Oracle has to find the best possible execution plan. So that execution plan as well is going to be stored inside this shared SQL area. So the query SQL text, the query's ID, SQL ID, and the query's execution plan will have to be stored inside the shared SQL area. Okay. Now, why is that required to store all that information inside the shared SQL area? Again, going back to the same example, if the user keeps on firing the same statement again and again after every 10-20 minutes, it doesn't make sense for Oracle to generate the execution plan every time for the same query, right? Because it has to spend some time and some resources on generating those execution plans, right? So it will not generate the execution plan again and again. So for enhancing reusability in the database, Oracle stores all this information inside the shared SQL area, so that next time when the user or any other user in the database, okay, if next time the same query is fired by any other user in the database, Oracle will be able to use the same execution plan to fetch the result set of that specific query. Oracle doesn't have to spend time and resources in generating the execution plan. Getting it?
Yes, yes, yes.
Yeah. Okay. Sorry. So whenever a query is fired for the first time, of course, because it is being fired for the first time, Oracle will not have that query previously stored in the shared SQL area. Okay. So if the query is being fired for the first time and it doesn't find a previous occurrence of that specific SQL in the shared SQL area, in terms of Oracle, it will be called as a hard pass. Okay. If the query is being fired for the first time, it doesn't find any previous occurrence of execution occurrence in the shared SQL area, it is called as a hard pass. But if the same query gets fired again after some time and Oracle finds that the same query was fired previously, say 5 or 10 minutes ago or about an hour ago, in that case, it will be called as a soft pass. So what exactly is the difference between hard pass and a soft pass? Hard pass will be for the queries for which Oracle has to generate an execution plan, okay, for the first time. Next time, if the same query, if the query is able to use a previously generated execution plan, okay. Now understand that definition, okay. If the query is able to use a previously generated execution plan, it will be called as a soft pass. Clear with the difference?
Yes, bro.
Abhishek,
Yes, yes,
Azaz,
clear,
Mani,
clear, clear. Yes.
Mani, Mani has been quiet today. Okay. Okay, so that's what Oracle wants to achieve by storing all those SQL statements and the execution plan in the shared SQL area. Now the problem is the database. In the database, there will be hundreds of users who keep on connecting to the database, right? And they will keep on firing queries in the database, right? Or the applications will keep on hitting queries in the database. Now for Oracle, it is not possible to store all those queries, their SQL text and the execution plan in the shared SQL area. Okay. It is not going to be possible. I mean, it is not an infinite amount of storage that is available to store all the SQL statements permanently. Okay. So what Oracle does is Oracle makes use of something called as a LRU algorithm, which is least recently used algorithm. Okay. So let's say that internally Oracle has allocated 2 GB of memory to the shared SQL area. Okay. Now, there will be a time during the day or in a couple of days wherein this 2 GB that was allocated to the shared SQL area, it gets full. Right? It can't, I mean, after there will be about, say, a few thousand SQL statements that will get stored in the 2 GB, right? Now, if a user comes in and he fires a completely new statement, okay? So for generating the execution plan of that specific new statement and storing its execution plan, there is no free space available in the shared SQL area because all that 2 GB has been occupied or it is preoccupied due to the previously stored execution plan and SQL statements. So what does Oracle do in that case? Oracle has to apply that least recently used algorithm and free up some space by purging some of the older SQL statements which are not being used again and again. Okay. So let's say that if this was one of the query, this is another one, another variant of the same query. Let's take another example. Okay, here let's give it as Noida. Okay. Now, if you see here, there are multiple executions of this query wherein the users want to see the details of employees from Mumbai. There are multiple executions of this query wherein the user wants to see the details of location Noida. Okay. However, there is only a couple of executions or two executions of this query wherein the user wants to see the data from Hyderabad location. Now, assuming a scenario that the shared SQL area has now become full, okay? Out of these three SQL statements, which one Oracle will purge to make space for a new query that comes in? Let's say that the user has fired a new query, okay? And he wants to see the data from, say, okay, if this is a completely new query that has been fired for the first time, and the shared SQL area, there is in the shared SQL area, there is no free space available. So out of these three queries, which one will be purged?
Hyderabad.
Everyone saying Hyderabad?
Yes. Less frequent used query will be purged.
Deepak, Mani, Azaz.
It should be
What is the message?
Nagpur, I guess. Bro.
Nagpur,
Hyderabad.
you guess.
Hyderabad is the least used query, na? As you told.
Hyderabad
Exactly.
has come
Yeah, so it
twice.
will be purged. When we are
So exactly. That answer is correct. Okay, this query will be purged. Why this will be, Deepak? Nagpur query is, I mean, this query has come for the first time. Your query, Oracle needs to prepare the execution plan for this query. Okay, there is no free space available in the shared SQL area. So how come you are saying that this query will be purged? There is no space itself for, purging needs to be done in the shared SQL area. So how come you are saying that this query will be purged? Hello.
Hello, bro.
yes,
Yeah,
yes.
I got disconnected in between. Yeah, let me share my screen again. Share, yeah. So the answer about this query with Hyderabad location is correct. Okay, because the users are not firing this query repeatedly. Okay, so that's why Oracle will purge this specific query from the shared SQL area. So what is the criteria for purging the queries from shared SQL area? Okay. Whichever query which is not being fired repeatedly again and again, that specific query can be purged out to make space for new query that is coming into the database. Clear with that?
Yes, 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 clear.
Yeah. So Oracle makes use of the LRU algorithm to make space for the new queries. Okay. And it has to store all those query execution plans, query SQL ID, so that it can enhance the usability in the database, so that we can see more and more soft pass in the database. And from database performance point of view, you as a DBA, you will try to target for more than 90 or 95% of soft parsing in the database. Okay. So when you generate a database performance report, if you see that the soft parse percentage, okay, there is something called as a AWR report in case of Oracle. If you see that soft parse in the database is less than 80%, then it is really not a good scenario. Okay. Above 80, it would be fairly acceptable. Okay. But having your target or your aim would be to have a soft parse ratio of more than 90%. Okay. And how do you ensure, or how do you try to ensure reusability in the database? Again, going back to the same example, see, if all these users, say, who are trying to fetch the data for Mumbai location, Hyderabad location, and Noida location or Nagpur location, if all of them had used this specific query, okay, the placeholder query, in that case, all of them would be using a same single query, right? There won't be a requirement for Oracle to generate the execution plan separately for, say, Mumbai location, then for Nagpur location, for Noida, and for Hyderabad. Right? You're getting it? Anyone?
Uh,
Abhishek?
bro,
Sorry, I was disconnected. Sorry, I was disconnected.
Okay. So what I was saying, to enhance the reusability in the shared SQL area, we make use of these placeholders in the query. Okay. If instead of all these queries wherein the users are manually giving the location by themselves, like Hyderabad, Mumbai, or Noida, or Nagpur, if all of them were using this specific query, select name comma manager from employees where location equals to a placeholder name, internally Oracle would use the same execution plan for all of them. Why? Because the location value, it is being provided, or the user will provide that value at runtime. You're getting it?
Yes, yes, yes.
So that's why as a DBA, you will ask the users not to make use of literal values. You ask them to make use of bind variables, placeholders. Okay. The next memory component that we see inside library cache is shared PL/SQL area. So there is not much difference between shared SQL area and shared PL/SQL area. It's just that the shared PL/SQL area is dedicated for the PL/SQL packages and procedures. Okay, it does the same set of tasks as being carried out by the shared SQL area. SQL area is for SQL statements only. It is not for the PL/SQL blocks, like the programming logic blocks that you see for and while loop, all that thing. If that comes into picture, it goes into the shared PL/SQL area. Clear with that?
Yes, yes, yes.
So that is about shared SQL area and shared PLSK SQL area. The next thing that is present inside library cache is private SQL area. We'll come to this later on. Okay, we'll discuss this later on, maybe tomorrow. After this, the next component that we see is data dictionary cache. Okay, now what exactly is the data dictionary cache? In case of Oracle, we have got various informations that is internally present within the database itself, which the database uses for itself as well. Okay, all those information like how many users are present in the database, at which date the database was created, what is the name of the database, what is the current size. So all those internal information, okay, all that information related to the database itself is stored inside something called as a data dictionary. Okay, and what is the data dictionary cache? So a copy of all that information, okay, it gets loaded inside the memory, that is inside the SGA, okay, inside the shared pool. There it is called as data dictionary cache. Okay, so some of the information which I just mentioned, like say DB name, okay, size, creation date, version of the database. So all these are database internal information. Okay, so these informations are stored into something called as the data dictionary. Okay, all these information will be stored inside the data dictionary. Apart from this, I mean, there are other hundreds of information that is getting stored. These are just very simple example of what all information are stored inside the data dictionary. So a copy of all that information which is getting stored inside the memory is called as the data dictionary cache. Okay, are you clear with this?
So basically, it will contain metadata, right?
Metadata, it is the metadata of the database.
Okay, okay, okay.
Okay. The next is again result cache. So we'll cover private SQL area and result cache in tomorrow's session. Let's wind up for the day today. Okay. I will pause or stop the recording. Just hold on.